Okay. This is a video on section 7.3. And during this video, that's solving trig equations, I'm going to solve several of your homework problems for you to help you out, to hopefully get you on the way to successfully completing many of these homework problems. So I'm going to begin with problem 13. Problem 13 says 4 cosine squared theta equals 1. Right? 4 cosine squared theta equals 1. So before we can solve the problem, we have to isolate the trig function. So to do that, I'm going to bring the 4 to the other side. I get cosine squared theta equals 1/4. I'm going to take the square root of both sides. That's going to get me cosine of theta equals plus or minus 1/2. Now, we solve trig equations the way we generally attack most trig questions. We say, well, what's my quadrant? What's my reference angle? This question is unique. It's different than what we've been looking at in the past, because instead of our cosine theta being positive 1/2 or our cosine theta being negative 1/2, we have cosine theta equals plus and minus. So when we draw our unit circle here, and we go, all students take calculus, we want where cosine is positive, that's quadrants 1 and 4, and we want where cosine is negative, that's quadrants 2 and 3. So for our quadrant, we get all 4. So that's a new twist on things for us. Now, when it comes to our reference angle, we're going to attack that the same way that we always have. We're going to say cosine is adjacent divided by hypotenuse. We're going to try to draw a triangle where we have a possible ratio of 1/2. And of course, we have that triangle, right? That triangle is our 30, 60, 90 triangle. We need cosine to have an adjacent side of 1, a hypotenuse of a 2. That's going to be this angle right here. We know that is pi/3. So our reference angle is pi/3, and we're in all 4 quadrants. So we come over to our circle, we draw an angle of pi/3 in quadrant 1. Here's our reference angle. We draw a reference angle of pi/3 in quadrant 2. Here's our reference angle. We draw an angle of pi/3 in quadrant 3. There's our reference angle. And we draw an angle in quadrant 4 with a reference angle of pi/3. And now, since we do not have to do any work to simplify theta, we know our answer. We have theta equals, in quadrant 1, we get pi/3. In quadrant 2, we're now at 2 pi/3. In quadrant 3, we skip 3 pi/3, right here. We skip 3 pi/3, so we're at 4 pi/3. And then in quadrant 4, we get 5 pi/3. So our answer to problem 13 is going to be pi/3, 2 pi/3, 4 pi/3, and 5 pi/3. Okay. So let's take a look and see what happens now with another homework question. All right, so let's just move down and we'll look. We did problem 13. We'll look at problem 19. Okay, problem 19. So what do we have in problem 19? Problem 19 says cosine of 2 theta equals 1/2. So this problem is different than problem 13 because in problem 13, we just had one theta here. We didn't have to make a substitution. Now, our method of solving a problem when this is not just one theta or one x or one alpha is we come in and we say, and I'm going to choose alpha, let alpha equal 2 theta. And I'm going to resubstitute in place of 2 theta. I'm going to resubstitute alpha. And I'm going to get now cosine of alpha equals 1/2. And I'm just going to proceed as if this was the question that they gave me. So I'm going to write down quadrant. And I'm going to write down reference angle. Now this problem, 19, turns out to be very similar to problem 13. That's why I left problem 13 on the board. However, instead of plus and minus 1/2, over here we took the square root, it got us positive and negative. Over here we just have positive. So when we draw our unit circle, we ask ourselves, all students take calculus, what quadrant am I in if cosine is positive? Here we get quadrant 1 or quadrant 4. Right? Quadrant 1 or quadrant 4. Now for our reference angle, we've already done the triangle right here, right? We know that this is adjacent over hypotenuse. We're using the same trig ratio here that we used to do problem 13, and we have 1/2. So we're going to have a reference angle of pi/3. Now, instead of drawing pi/3 in all 4 quadrants, we of course have pi/3 in quadrant 1, and we have pi/3 in quadrant 4. So now our answer, remember now, we're solving for alpha here. We're going to have alpha equals pi/3, or we're going to have alpha equals 5 pi/3. Now, that's not what we were asked to find. We were asked to find theta. So our problem-solving strategy here, our methodology says, when we have to do a substitution, we tack on plus 2k pi and plus 2k pi. 2k pi, because this is cosine, and the period of cosine is 2 pi. If this had been a tangent problem, this would be 1k pi. If this had been a cotangent problem, this would be 1k pi. It's 2k pi because it's a cosine or a sine or a secant or a cosecant. Now we're going to resubstitute in the value of alpha. Alpha is, according to here, 2 theta. So we have 2 theta equals pi/3 plus 2k pi, or we have 2 theta equals 5 pi/3 plus 2k pi. And now we just proceed. We solve for theta. We're going to multiply everybody by 1/2, right? That's how we get rid of the 2. So we get theta equals, when we multiply here by 1/2, we get pi/6. When we multiply here by 1/2, right, we would have a 2 down here. We get k pi. Over here, we get theta. We multiply by 1/2, we get 5 pi/6, right? Here, when we multiply by 1/2, we're going to get plus 2k pi. Remember, we multiplied here by 1/2, and we multiplied here by 1/2 to cancel the 2. Now, in the instructions to the problems, it specifically asks us to find only the solutions contained in the interval 0 to 2 pi. So when we reach this step right here, now if it did not say that, right, if it did not say find the solutions in the interval from 0 to 2 pi, then we are finished with it. We're finished. This gives us all the solutions on the unit circle that solve cosine 2 theta equals 1/2. And we simply say k is an integer. K is 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And that would give us the infinite number of solutions to our problem. But they, in this question, specifically asked us to find just the solutions between 0 and 2 pi, just between 0 and 2 pi. And so to find those solutions, we look at our values of theta and we start substituting in values of k. Okay, we say, well, let k equal 0. If k is going to be 0, this side's going to be theta equals pi over 6 plus 0 times pi, or just pi over 6. And I check and I ask myself, is that contained in the interval? And the answer is yes. So that's one of my answers. Or we get theta equals 5 pi over 6 plus 0 pi. I'm letting k be 0. That gets me 5 pi over 6. And I ask myself, is 5 pi over 6 contained in 0 to 2 pi? And sometimes I find it helpful. When I get to this step and I see my answer is in terms of over 6, I come up here for my 2 pi and I just write off to the side over here, that's 12 pi over 6. Right? I just kind of write that so I can keep in mind that's what I'm allowed to meet. Actually, not even meet because it's open at 2 pi. But I can't have a 12 pi over 6, and I can't be bigger than 12 pi over 6. So we tried k as 1. Both of those work. So now we're going to let k equal, we tried k as 0. So now we're going to let k be 1. So this would be theta equals pi over 6 plus pi, right? Because k is 1, so that's plus pi. Now, pi is really 6 pi over 6, isn't it? If we get a common denominator. So here we get theta equals 7 pi over 6. And we ask ourselves, is that in my interval? And yes, it is, because I'm allowed to go up to, but not equal to 12 pi over 6. I'm not there yet. I come over here to this one, I get theta equals 5 pi over 6 plus 1, k is 1, so that's going to be pi, which is, of course, if I get my common denominator, 6 pi divided by 6. I add those together, and I get 11 pi over 6. And I ask myself, is that okay? And the answer is, yes, it is. Because I'm not over or equal to 12 pi over 6. Now, we're going to go ahead and let k be 2. I think you have an idea here that this is probably going to be too big, because when we write this down, look what it says. It says theta equals, right, k is 2, theta equals pi over 6 plus 2 pi. Well, let's just think about what that means. If we're adding 2 pi, right, let's just draw ourselves a unit circle right here. Here's pi over 6, 30 degrees. If we add 2 pi, we're going to go all the way around 12 pi over 6, because 12 pi over 6 is 2 pi. So we're going to be too big here. So this we're going to get rid of. By a very similar argument, of course, over here we're going to have 5 pi over 6 plus 2 pi. That's going to be too big as well. So we're going to have 4 solutions to problem 19, 4 answers, right? And they're going to be the answers we have right here on the board. Okay, so this is problem 19. This is our strategy. This is what we're going to do. But our number 1 priority, right? Our number 1 priority should be copying the problems down correctly. Because I just noticed as I was talking to you, I glanced up at my book and I was going to do problem 25 next, which is 2 lines down from problem 19. And when I glanced up, I noticed problem 19 in your book is actually -1/2. So I actually didn't do problem 19 for you because I did +1/2. So if you were probably screaming at the computer from the beginning, but of course I didn't hear you when I was making this video, but I appreciate that. We were supposed to do quadrant 2 and quadrant 3 to do problem 19. But at least I showed you the steps, right? You can just mimic these steps. The only difference would be, of course, you would probably want to use the correct problem 19, but the video isn't about doing your homework for you. The video is about helping you how to do your homework. So these are the steps that we use to solve a problem like problem 19. But of course, if we were actually doing the problem 19 in your book, well, we would have to, write the problem down correctly. Now, it wasn't on purpose. I just messed that up. But so the answers you're going to get are going to be a little bit different, but you can follow this strategy and still get the correct answers. All right, so let's look at another one. And let's, this time I'll try to actually copy the problem down correctly. Let's see if I can at least start with the correct problem. All right, so let's see if we can do a problem. We'll see if we can copy it down correctly and see if we can actually solve it correctly at the same time, right? So we did problems 13, we did 19. Let's jump down to something like problem 25, okay? 25. Now, problem 25 is a tangent problem, and it says tangent of theta plus 1 equals 0. So remember, our first task is to isolate the trig function. So this says tangent theta equals, we're going to move the 1 across, and we get -1. Okay. Now we're going to start with quadrant and reference angle, just like before. We're going to draw our circle. We're going to ask ourselves, what quadrant would we be in if tangent's going to be negative, right? So we got tangent is negative in this quadrant and negative in this quadrant. So we're in quadrant 2 or quadrant 4. All right, so those are our quadrants, 2 or 4. And now we need our reference angle. Now, this is one of those problems where they give us one number, but we have to remember that it's really a ratio, right? Trig ratios. So we need a triangle. Tangent is opposite over adjacent. So I need a triangle with a 1 for my opposite and a 1 for my adjacent. Of course, that's my 45, 45, 90. So my reference angle is going to be pi over 4. Okay, pi over 4. So we draw our reference angle in quadrant 2, right? Quadrant 2, we draw pi over 4 reference angle. We go to quadrant 4, we draw pi over 4 reference angle. Now, we did not have to do any substitutions. This is strictly theta. It's not 2 theta. It's not theta plus 6. It's just theta. So now we have theta equals, this angle is 3 pi over 4, or theta equals, that angle right there is 7 pi over 4. Now, because again, in this problem, they asked us only to solve between 0 and 2 pi, only one revolution, we are done. If they had said, find the general solution, right? Find the general solution, which means all of the solutions, then we would have attached k pi here. We would have attached k pi here. We would have told them k is an integer. And that would solve for all solutions to the equation tangent theta plus 1 equals 0. But we were asked, specifically, we were asked to only find those solutions between 0 and 2 pi. If you look down in your homework at problems 35, 36, 37 through 44, problems 35 through 44, down there, they remove this stay within 0 to 2 pi condition. All that means is we just attach this. Okay, we just attach this, and then we say k is an integer. Of course, if this had not been theta by itself, we would have had to attach the k pi anyway to solve the problem. Just like we did in problem 19, we still attached 2k pi to both our solutions, and then we multiplied everybody by a half. So that's problem 25. Okay. Let's take a look at another one. All right, let's take a look at another one. So let's take a look at 31. All right, 31. So here we get cosine, and we get 2 theta minus pi over 2 equals, and we'll see if we can write it down correctly. I'm pretty sure it's supposed to be -1. All right, now this is a different type of problem. Here we just had 1 theta, and we had a 1 on the left-hand side. We had to move it across. We don't have any numbers over here. We've got a -1 over here. Okay, we've got a -1. But we have an expression in here, and we're going to have to get rid of that. We're going to let alpha equal 2 theta minus pi over 2. Okay, that's the way we do that. You don't have to choose alpha. That's just what I choose. So now we have cosine alpha equals -1. Now, I picked problem 31 on purpose. Okay, I picked problem 31 on purpose because it's one of those questions that we have to be ready for where they've given us a trig function and they've given us a value that happens to occur on one of the axes. See, typically when we get a single number over here, we think to ourselves, okay, I'm going to do quadrant. I'm going to do reference angle, right? That's our approach. And then we think to ourselves, well, all right, you're really trying to just play with my head here. That's really a fraction. So I'm going to write that as a fraction. I'm going to look at this as negative. I'm going to go, all students take calculus. I'm going to think cosine is negative in quadrant 2 and quadrant 3. I'm going to write quadrant 2 here or quadrant 3. This is what we typically do to solve these problems. We get to our reference angle, right? We get to our reference angle and we go, okay, cosine is adjacent over hypotenuse. And it's at this moment that we might start to get a little uncomfortable because we know from geometry that the hypotenuse of a right triangle is longer than both legs. And here we are being asked to have the adjacent side be 1. Remember, we took care of the negative with the reference angles. The adjacent side is going to be 1. And the hypotenuse is also going to be 1. Now, we know we cannot draw that triangle. That triangle does not exist. And so then we have to pause, right? We have to take a deep breath, pause, don't panic, just pause and ask ourselves, wait a minute, what's happening here? Now, if we take a different, right, a different perspective to this, cosine looks like this. This is the cosine graph. Now, we have been told specifically to only focus between 0 and 2 pi. And we've been asked, When does cosine equal -1? Well, cosine equals -1 right there. And we know that that's 3 pi over 2. So we have to be aware of this type of question. That's why I wanted to work it into the little video here I'm doing for you to help you with your homework. This is one of those problems where it's not going to help us to do our unit circle and our right triangle to find our quadrant and our reference angle. Now, before we get frustrated by that, realize if we went with this approach does not solve the problem. I agree with that. But it does indicate to us that we are going to have to take a different look, right? Because we get to this step right here, we just follow the steps like we normally would follow the steps. We don't try to outthink anything or overthink anything. And we get here and we say, oh, okay, adjacent over hypotenuse. Uh-oh. And when we get to an uh-oh, and uh-oh means pause, right? Just take a look at what we're working on. We've got cosine equals -1. That we know that happens. It happens right here. So when we get all done with doing this problem, right, we have to solve it by taking a look at the graph or thinking about the fact that this is x is 0, y is -1. This is, it's not 3 pi over 2, is it? This is just pi. Thank you. This is pi over 2. That's pi. That's 3 pi over 2. So this is -1, 0. So we're right here at pi. Right? We don't have a reference angle for this problem. That happens every now and then. We land on the quadrants every now and then. So what am I going to do to solve the problem? Well, I'm going to do the same thing I've done before. I'm going to say alpha equals, right? And my angle is pi plus, and because I'm doing cosine and because I had to do my substitution, I write 2k pi right there. 2k pi because it's cosine, right? Because it's cosine. And now we're going to resubstitute in. We have 2 theta minus pi over 2 equals pi plus 2k pi. Just like we did in problem 19, we're going to resubstitute. This time, instead of having this or another solution, because we ended up on one of our quadrants, we only get one solution. Now, what do? We move the pi over 2 over here. 2 theta equals, we have pi plus pi over 2. That's going to be 3 pi over 2 plus 2k pi. Now we divide everybody by 2, multiply over here by 1/2, and we get theta equals 3 pi over 4 plus, multiply by 1/2 here as well, k pi. Now, how are we going to find our answers? Well, we're going to say, let k equal 0. And instead of having 2 possibilities like we did on problem 19, we're only going to have 1. So k is going to be 0, so that's going to give me theta equals 3 pi over 4 plus 0 pi, right? K is 0, so that gets me 3 pi over 4. Then I'm going to say let k be 1. That's going to get me theta equals 3 pi over 4 plus pi, right? Because k is 1, so 1 times pi, which if I get a common denominator is 4 pi over 4. So now I'm up to 7 pi over 4. And then what happens if k is 2? Right, let's look right here. If k is 2, that's going to be 3 pi over 4. Right? 3 pi over 4 is right here. Plus 2 pi. So when we add 2 pi, to 3 pi over 4, we're going to pass our limitations, right? Remember our limitations were 0 to 2 pi. And what I like to do is I like to take my 2 pi, and since I'm working with over 4, I like to write that as 0 to 8 pi over 4, and that way I know when I have to stop. So our answers here, we have 2 of them, right? We get theta equals 3 pi over 4, 7 pi over 4. All right. So I've done 4 of your homework problems for you. Hopefully by watching this video, and you can watch it as many times as you want, you'll be able to finish the rest of your homework problems. Remember, we have a quiz this week on sections 7.1, 7.2, 7.3. So this will be on our quiz. Okay. So everybody finish your homework, and I will see you when we get together this week. All right, thanks for watching.